Welcome to Emilac Online Tutorial. Now before us is this topic that we'll be looking into trigonometry ratio. Okay, and in this trigonometry ratio, what we'll be focusing on is a right angle triangle. That is the relationship between the respective angles, a right angle triangle. And what is a right angle triangle? A right angle triangle is a angle that is formed two sides forming a 90 degree. That is, two sides of a triangle forming a 90 degree is a right angle triangle. Okay, now basically let us know what trigonometry is all about. Trigonometry talks about the relationship between the angles in this triangle and the sizes. I repeat that again. Trigonometry talks about, or is just the study of the relationship between the angles in a triangle and the sizes of the same triangle. Okay, all right. Now let us also put to notice that the size of a triangle facing the angle 90 is called the hypotenuse. Yeah, the size facing the right angle triangle, the size facing the angle 90 in a right angle triangle is called the angle 90, and the vertical size is called the opposite, and the horizontal side is called the adjacent. Okay, and this brings us to remembrance the Pythagoras theorem that says the square of the hypotenuse equals to the sum of the respective squares of the other sizes. Okay, now here is the hypotenuse, the square, now the opposite, and the adjacent. Alright, now this is called the Pythagoras theorem, and this also will help us, knowing this also will help us to simplify problems when we start dealing with the special angles of a trigonometry ratio. Alright, now let us move further. Still making use of the right angle triangle. Now let us label the vertex of this triangle A, B, and C. Now the sides opposite to this here we label as small letter A. Now the sides opposite B, this we label as small b, and this here we label as what? Small letter C. This looks bigger than, okay, small letter C. Alright, and let's have this as the angle theta. Okay, now take note from the Pythagoras theorem. Here is the hypotenuse, here is the adjacent, and here is the opposite. Now let us now look for the relationship between these sizes and this angle. Right, now you can see that here the relationship between this opposite and hypotenuse here. So here we have the relationship between the hypotenuse, the opposite, and the hypotenuse in relationship to this angle here is the sine. So here we have the opposite over the hypotenuse. Right, now here the other one, which is cos theta. Here we have the adjacent and the hypotenuse. That's the relationship between the adjacent and the hypotenuse. That will be what? A over cos hypotenuse. Now we have the tan theta, and the tan theta here gives us the relationship between the adjacent and the opposite. So here you have the opposite rather for the adjacent. Now this Now, in a short form, gives us so ka tua. Right? Now, this is the sine, angle, then the opposite hypotenuse, which is this. Now the cos, which is this, adjacent hypotenuse, this is it. Now the tan, theta, which is this, opposite and adjacent, which is this. Alright, now this is also one of the basics of trigonometry. Now take note that we've also put to remembrance, or we could recall the Pythagoras theorem, where hypotenuse, the square of the hypotenuse, equals to the what? To the sum of the respective squares of the other what? Sizes. Okay, now since we've established the sukatua, that's the relationship between the angles and the sizes, and this Pythagoras theorem is now the relationship between the respective sizes of a right triangle. Now let us now move further to finding the values of the special angles of trigonometry ratio. Now, talking about the special angles in the trigonometry ratio, in trigonometry. Now, the common or the special angles are 30 degrees, 60 degrees, and 45 degrees. Okay, now these are the most common special angles in a trigonometry. Now let us come here. Now here we have a right angle triangle. Okay, now and this is also another right angle triangle, but with two. If you probably have this here, you can see here we have a right angle triangle, here we have a right angle triangle. Now this is a right angle triangle with 45 degree as the two other sides, and here this is also another right angle triangle too, with here 60 and here 30. That is when we divide through. Okay, let us see. The whole of this side is 60, which makes this triangle an equilateral triangle because all the angles are the same, right? Now for this 45 degree, now this makes this an isosceles what? Triangle, because this length and this length are the same. Now here, take note here, let me put it this way, okay? Alright, now from this, let us now derive the expression or the formulas for trigonometry functions. Now if this angle, this size and this size is the same, so we can represent it as one unit. Okay, now same thing here. If we have this size, this side, this side the same, so we can actually, for convenience's sake, we can represent it as 2 units, 2 units, and here 2 units, right? Okay, let us mark this A, B, and C. Let us mark this A, B, and C. Okay, now let us now recall the SOHCAHTOA. And the SOHCAHTOA says sine theta equals opposite over hypotenuse, then cos theta adjacent over hypotenuse, and tan theta opposite over adjacent, right? Okay, so ka tua. Okay, now if this is equal to this, Now let us now bring back the Pythagoras theorem that says that the hypotenuse, the square of the hypotenuse equals the sum of the respective square of the other sides, which is the opposite and the adjacent. Alright, solving this now that we know that this side and this side are the same, so we represent it as what? 1 unit. Okay, now let us find the value of the hypotenuse of this triangle. Now bringing this, using this hypotenuse theorem, so we can say that the hypotenuse of the 45-degree triangle, so here we have the hypotenuse. Now the opposite here is 1, the adjacent here is 1, and this will give us 1 raised to the power of 1 is 1, and 1 to the power of 1 here is 1, which will give us what? 2. So the hypotenuse here, squaring both sides, okay, so squaring both sides here, so here we have that h equals to what? 2. Now take note, why I tend to ignore the plus or minus here is we can't have a negative value of a length, so that's why I ignore the plus and minus. Okay, so sorry, that'll be the square root of 2. So here we have that this hypotenuse here is the square root of 2. Okay, now this is it for the right angle triangle having the 45-degree. Now let's move to the right angle triangle that is having the 60 and the 30-degree. Now since we've divided this into equal parts, it means that here will be 30-degree and here will be what? 30-degree. Alright, now putting this into consideration, now you can see we can draft out one right angle triangle, right? Okay, which implies since from here to here is 2, we can also represent here to be 1, right? Okay, let me clean this. Okay, now bringing back the Pythagoras theorem and solving this to get the value of the hypotenuse here, sorry, opposite rather, not the hypotenuse. Now the hypotenuse here, which is the longest side facing the right angle, here you have what? 2, so here you have 2 raised to the power 2. Now the opposite, which is this, so here we have okay, unknown, then plus the adjacent, here we have what? 1. Okay, alright, so please don't mistaken this to be 0, this is opposite. Okay, so here we have 4 equals to the opposite, now plus 1. Alright, subtracting 1 from both sides, we are left with 3 equals the opposite, raised to the power 2. Okay, now finding the value of the opposite here, we can now square both sides, and by squaring both sides, here we have the square root of 3, then equals to the square root of the opposite all raised to the power 2. Now this will eliminate this. At the end of the day, we have that the opposite equals to the square root of 3. So which means this is the square root of, the opposite now is the square root of what? 3. Okay, now that we've established the various value of the sizes of the triangle that contains the 45-degree and the 60 and the 30-degree of a right angle triangle, now let us now establish the values of sine theta, cos theta, and tan theta. Alright, now let us look at the sine 45-degree, the cos 45-degree, the tan 45-degree, the sine 30, the cos 30, tan 30, and 60-degree respectively. Now let us also recall Now from our SOHCAHTOA, we know it is a SOHCAHTOA. That will be sine theta will give us opposite over hypotenuse. Now the cos theta will give us adjacent over hypotenuse, and the tan theta will give us the opposite over what? Adjacent. Okay. Now let us start with sine 45 degree. Now from sine 45 degree and the sine here we have what? The opposite over what? The hypotenuse. Now irrespective of which of the angle, as long as they're the same, we can make use of any one. Now okay, let's make use of this. Now for 45 here we have the opposite over what? Hypotenuse. This is the opposite and this is the what? Hypotenuse. Now and as such here we have opposite, that will be 1 over the root of what? 2. Right? Okay. Now basically according to the rule of surd, you don't leave your answer having the decimal to be a surd. So when we rationalize this will give us root 2 over 2. Right? So now sine 45 now will give us what? Root 2 over 2. Okay, now we've established that. Now for cos theta, now if you look at cos theta, now you can pause the video and get to know the value of cos theta using this rule, adjacent over what? Hypotenuse. Alright, very good, and I'm sure you got it right. Now adjacent here, you can see this is the 45 we're making use of. Now the adjacent here is 1, then over the hypotenuse, which is what? The root of 2. Alright, which also give us the same answer as this, root 2 over 2. Okay. Alright, now but take note, if it were to be this is just the opposite, and here will be the adjacent to this angle. Alright, let's move to tan 45. Tan 45 here, according to the ratio here we have the opposite over what? The adjacent. Since we're making use of this 45 here, now our opposite here is 1 and our adjacent here is 1. Alright, so tan 45 is equals to 1. Okay, now let's now move to 30 degree using this. Now from here, sine also we know it is what? Opposite over what? Hypotenuse. Now taking cognizant of 30 degree here, now the side facing it or opposite it is called the opposite. So in relationship to 30 degree, this side is the opposite, and in relationship to 60 degree, this side is the what? The opposite, but this remain the hypotenuse. Alright, for angle 30, which is what? Opposite over what? Hypotenuse. So here we have the opposite, this here, this is the opposite, which is what? 1, then over the hypotenuse, which is what? 2. So sine 30 is what? 1 over 2. Now for cos 30, now for the cos is the hypotenuse, adjacent over what? Hypotenuse. Now take note that this is 30. Now if this is the opposite, definitely this will be the what? The adjacent. So here we have the adjacent, which is what? Root 3, then over the hypotenuse, which is what? 2. Alright, very good. Now you can pause the video and get the value for tan 30 now using this. Alright, so moving further, tan 30 here, take note, the relationship here is what? Opposite over what? Adjacent. Now opposite over adjacent here, 30, this is our opposite, which is the what? 1, then over the adjacent here, for in relationship to 30, the adjacent is what? Root 3. So here we have what? Root 3, which will also give us root 3 over 3, which means if we rationalize this, it gives us this. Okay, now moving further. Alright, now let's move to 60 degree, and I believe with what we've done so far here for 45 and 30 degree, you can pause the video and get the answers to 60 for angle 60. Okay, now let's solve for sine 60 here. Take note, this is our 60, which implies that the side opposite to 60 here is the opposite. Now the side beneath it is the adjacent, while this long side, or which is 2, remains the hypotenuse. Alright, for sine 60 here, now which is what? Opposite over what? Hypotenuse. Now our opposite here is root square root of 3 over our hypotenuse, which is 2. Okay, now the cos 60. Now cos 60 here we have the adjacent over hypotenuse. Now this is 60, the adjacent is 1 and hypotenuse, so here you have what? 1 over 2 for cos 60. Now tan 60, right? Tan 60 here we have the opposite over adjacent, so here we have this 60, the opposite over adjacent, which is root 3 over 1, which will give us what? Root 3 as the final answer. Alright, and I believe you've learned something in this tutorial. At least we'll be able to establish the Pythagoras theorem, from which gives us the relationship of the sides of a right angle triangle, and the SOHCAHTOA, which gives us the relationship between the angles in the triangle and the sizes of the same triangle. Okay, and from in conclusion also, we're able to establish how to get the trigonometry ratios of the special angles, which are what? 45, 30 and 60. Now you having this now will help you to solve problems in trigonometry. Now let us solve this. Now you can see these are the varieties of our right angle triangle with a known size and unknown size, a known size and unknown size, a known size and unknown size, a known size and a known size, and we are told to find the unknown size. Now let us recall. And you can see here we have, before that, we have the angle 45, angle 45, angle 30 and angle 60. Now let us now bring back to memory the trigonometry ratio. Now I'll be using the triangle. Take this for the 45, here for the 45. We know that this side and this side are the same, so this is 1 and 1, and using the Pythagoras theorem, here will give us root 2, and for the angle 90, for 60 and 30. Okay, let's make use of this. And here we have the 60, here we have the 30. Now here is the 2, here is 1, and here is root 3. Okay, now let us start with this. Now you can see that this angle is facing the sides of the unknown, which means this is the opposite, and the longer side that, or the side that faces the angle 90, is the hypotenuse. Alright, now let us now solve this, which is the unknown. You can see the relationship between this unknown and this unknown here. You can see that this is opposite and this is what? Hypotenuse. Now the angle here, this and this will give us what? This is what? So, which means what? Sine, opposite and hypotenuse. Alright, to solve this now we can see this is sine 45, right, equals to the opposite, which is over 4. Now for sine 45 here, in respective of this, now which is what? Opposite over hypotenuse. So here you have the, if we can make use of this one, this is the opposite over the hypotenuse, which gives us 1 over root 2, which is equal to x over what? 4. And this also will give us, this is according to rationalization, we have root 2 over 2 equals what? X over 4. And if we are to make x the solution of formula, or we multiply 4 by both sides, so here we have 4 times root 2 over 2 then equals 4 times x over 4. So this, we eliminate this, 2 here 1, 2 here 2, so our x here will now be what? 2 root 2. Now for this, so here we can just clean this and write 2 root 2. Okay, now if you can, okay, let me solve this. All right, now by solving that, here we have now for this here, you can see that the angle here 45 faces this side, which means this is what? Opposite. Now the side that faces the right angle triangle is the hypotenuse. Now, and this will now be our what? Our adjacent. Now take note that the unknown here is the hypotenuse and the known here is the adjacent. Now the question now is, what is the relationship between this angle, the unknown and the known? You can see that this is adjacent, this is hypotenuse and the angle, and according to our SOHCAHTOA, okay, let me write that here, SOHCAHTOA, so that that one give us a clearer picture. Now you can see adjacent and hypotenuse. You can see here adjacent and hypotenuse, which give us what? Cos. So here you have cos 45. Now give us what? Adjacent over hypotenuse. Where is our adjacent? That will be 8 over y. Alright, now for cos 45 here, which is adjacent over hypotenuse, from here adjacent over hypotenuse, which is 1 over root 3, over root 2. So here you have 1 over root 2 equals 8 over what? Y. If we have to rationalize this, it becomes root 2 over 2 equals 8 over what? Y. Now let us multiply both sides by y to make y the solution of formula. So here we have this will give us y root 2 over 2 equals 8. Now multiplying both sides by 2 again, so here we have 2, okay, 2y root 2 over 2 times 2, equals 2 times 8. So this will eliminate this. So here we are left with y root 2 equals 16. Now let's divide both sides by root 2, and this will give us, let me move over here, this will eliminate this, and when we rationalize this, here we have that y equals to 16 root 2 over 2. So our y here will now give us 8 root 2 as the final answer. So this here we have what? 8 root 2 as the final answer. Okay, now you can pause the video and solve this to see if you'll be able to get the answer, and I'm sure you'll be able to get the answer. All right, now let's solve this together. For 30 here, you can see that k is our unknown and it's the side facing the angle 90, and the horizontal side adjacent to 30 is our adjacent. Now here we have the adjacent, and this is the what? Hypotenuse. Now you can see from here the relationship between these two sides and this angle gives us a car. So here we can see cos 30 now equals adjacent, which is 9 over k. Now cos 30, let's come here. Now here is our 30, and our 30 is adjacent over hypotenuse, which is the adjacent over hypotenuse, which will now give us root 3 over 2 equals 9 over k. Now when we cross multiply here, we have it that k root 3 then equals 2 times 9 will give us what? 18. Now we divide through by root 3. This will eliminate this, and by rationalization, here we have, okay, rationalization means multiplying both the numerator and the denominator by the denominator. So here we have, then here we have 18 root 3 over root 3 times root 3 will give us 3. And when you cancel out this, here we have what, 6. So here we have what, 6 root 3. Okay, so for this, here we have what, 6 root 3. Alright, now let's solve the last one to see if you're able to get it. Now for the last question, here we have 60 degree. Now I'm facing this side, which is the opposite, and this is the 90 degree. Now the side here we have the what, hypotenuse, which is the unknown. Now what is now the relationship between the opposite, hypotenuse, and angle 60? So here we can see opposite hypotenuse, which is what, sine. So here we have sine 60 give us opposite, that will be 3 over z, right? Now from here we can get the value of 60 and sine 60. So sine 60 here is opposite over hypotenuse, which means this is root 3 over 2 equals to 3 over z. Now when we cross multiply, here we have z root 3 then equals 6. That will be 3 times 2 times 6. 2 times 3 will give us 6. Now let us now divide both sides by root 3, so that we get the value of z. So you can see that the value of z is 6 all over root 3. But we cannot leave it like this. We have to rationalize. By rationalizing, multiply both sides, both the numerator and the denominator, by root 3, which will give us 6 root 3 over 3. Now 3 here 1, 3 here 2. So here we have 2 root 3. So the unknown side here will give us 2 root 3. Final answer. Alright, with the introduction of trigonometry and this example, I believe the knowledge and the basics of trigonometry has been established in you. Alright, subsequently I'll be solving more complex problems in trigonometry using these basic rules. Thank you and God bless you.